Welcome to this video. Visual assessment under the canopy are essential for orchard and forest management, enabling the monitoring of land and forest health. In this context, achieving precise registration between successive data capture sessions become essential. However, this is particularly challenging for under-canopy images across different data collection days, especially across seasons, due to the self-occluding geometry and temporal dynamics in the natural environment. This paper proposes an effective strategy for aligning noisy, sparse point clouds of tree-covered areas reconstructed from RGB images and their GPS positions. As shown in the pipeline, our method leverages GPS data and deep learning-based perspective to bird's eye view conversion to provide an initial estimate of tree positions. And we introduce an innovative strategy for extracting tree trunks and clean ground surfaces utilizing these features for precise alignment. First, let's take a look at the initial stage. The animation here illustrates the process of collecting input images sequences. A perspective view to bird's eye view network is trained to predict the top views from frontal images, as shown in the top right. This provides rough initial positions for trees. For each image sequence, a sparse point cloud is reconstructed by a structure from motion using CodeMap. In the following illustrations, we use the model based on images collected from an apple farm in the winter as the reference, and the model from the summer as the query for demonstration. To align the query model to a reference model, the next feature stage uses tree position points derived from bird's eye view conversion to segment an area around each tree. Then, further trunk centers and ground points are extracted for each tree segment. Collectively, we can extract the ground points and tree centers across the entire model. In the alignment stage, the ICP alignment of the extracted ground point is first performed to mitigate GPS inaccuracies. This is followed by a looped process that alternates between ICP-based alignment of the ground point and tree centers. To mitigate accumulated drift, trees within the query model are clustered into several batches based on their positions and distance vectors. Each of these batches gets aligned individually to the reference model. Finally, we obtain the aligned models. Again, using the weighted model as the reference as shown here, we compare the alignment performance of different methods. The gray point clouds represent the reference models, the weighted, while the yellow ones represent the aligned summer models. From the alignment of the walls in the red circle, the tree trunks, and the offset in that direction, we can observe better alignment performance in both horizontal and vertical directions with our model compared to other methods.